So we're seeing large language model agents stepping into really persistent, complex roles now, right? Things like automating web browsing or even complex software engineering.
Absolutely. It's a massive leap forward.
Yeah.
But there's a pretty significant bottleneck that our sources highlight. These agents, they aren't really learning strategically from their past actions.
Mm.
Yeah, it's like they treat every task as brand new. They discard all that potentially valuable experience and just keep making the same mistakes.
Okay, so they've got the power, but not the wisdom gained from experience, basically. Lack of strategic memory. Let's dive into that because today we're looking at Reasoning Bank. It's described as a novel framework aimed at letting these agents, well, self-evolve by distilling and organizing memory.
Exactly. And what's really interesting here, I think, is that Reasoning Bank isn't just about logging what the agent did. It's designed to teach the agent how to reason and, crucially, why some strategies work and, maybe even more importantly, why others fail.
Right, the why. We're going to unpack what's actually inside Reasoning Bank and how it manages this strategic learning. And this deep dive is brought to you by embersilk.com. Okay, so let's talk about the memory itself first. Most older agent systems, they stored, well, it was kind of like raw footage, wasn't it? Just long execution logs or maybe workflows that happened to succeed.
That's right. It captured the steps, sure, but it missed the chance to pull out the transferable reasoning patterns behind those steps.
So how is Reasoning Bank different?
Well, Reasoning Bank fundamentally shifts that. It works to distill these generalizable reasoning strategies into structured memory items. Think like title, description, content. Very organized.
Okay.
And the real kicker, the innovation, isn't just learning from success. It's about deliberately extracting knowledge from the agent's own self-judged failures.
Learning from failure, that makes sense for us humans, but how does an LLM agent, which you think learns best from positive reinforcement, actually leverage failure strategically? Doesn't it just introduce noise or confusion?
You'd think so, but that's the counterintuitive insight here. Failure isn't noise in this system. It's actually treated as maybe the most valuable data source.
Really?
Yeah, by analyzing those failures, the agent learns vital preventative lessons. He gets these counterfactual signals like, if I hadn't done X, Y might have succeeded. And the data really shows this. Reasoning Bank was the only approach tested that got better, up to nearly 50% higher success rates, specifically when failure data was added.
Wow, okay.
The other methods, the baselines, they couldn't make sense of it. Their performance often got worse when failures were included.
So it's genuinely abstracting the lesson from the failure, not just getting bogged down by the failed outcome.
Okay, so if you have this high-quality structured memory bank, how do you generate enough diverse experience to fill it effectively? That brings us to the scaling part, right? This memory-aware test time scaling, or
Yep.
MATS.
Exactly. So if you think of traditional scaling as scaling by breadth, just throwing more and more separate tasks at the agent.
Like hiring more people for different jobs. Right. Mass scales experience through depth. It's more like giving your single best expert way more time and computational resources to really drill down on one tough problem. It allows for much deeper exploration within a single task instance.
Ah, okay. So the quality memory from Reasoning Bank helps steer that deeper exploration, making it more efficient.
Terrific.
And then the diverse experiences generated during that deep dive refine and enrich the memory bank even further. It's a positive feedback loop.
It's a really powerful synergy. The high-quality memory steers MATS towards promising avenues, and the varied rollouts generated during that deep exploration forge even stronger, more nuanced memories.
And this actually works in practice. What were the results?
The results were pretty strong. We saw up to a 34.2% relative improvement on certain benchmarks because of this synergy, but maybe even more telling is the efficiency gain.
How?
The agent used, on average, 2.1 fewer steps to succeed. That shows the generalized memory isn't just helping it succeed more often, it's helping it make more purposeful decisions, avoiding wasted effort and redundant exploration. It's developing, you could say, a kind of intuition.
Okay, so pulling it all together, Reasoning Bank plus MATS seems to represent a new angle on agent development, focusing on memory-driven scaling to build agents that don't just act, but adapt and learn over their lifetime, moving beyond just executing tasks to actually evolving strategy.
That's the big takeaway.
Mm.
And if you look a bit further out, what's really fascinating is the emergent nature of the strategies. They aren't fixed.
Mm-hmm.
You see them evolving from simple step-by-step procedures towards more complex adaptive reasoning. It even hints at a path towards compositional memory, where these learned strategic units could potentially combine in new ways to tackle even longer horizon, more complex challenges. That suggests a route to perhaps deeper general intelligence down the line.
That idea of emergent evolving strategies is definitely something to think about. Thank you for walking us through this architecture. And thanks to you, our listeners, for joining this deep dive. You can find out more about our sponsor at embersilk.com.